Okay, so kinetic energy. This is our definition of moment of inertia I. For any rotating object, rotating about some axis or some point at angular velocity omega, I is whatever you got to put here to get the kinetic energy. Okay? Now, so let's use this. First of all, we find the kinetic energy at 250 gram masses. We want to find the moment of inertia. We want to find the I. We're going to first find the expression for the kinetic energy, right? Kinetic energy of 250 gram masses, each 30 centimeters from the axis of rotation, the thing that we observed in lab. Okay? So kinetic energy is 1/2 mv squared. It doesn't mean you get to put omega in for v. It doesn't mean you get to put m in where I is, right? You don't get to do that. The units don't work out, and that's a big old red flag, right? So if you just happen to do that, which is easy enough to do if you're in a hurry, if you check out the units, you'll see that red flag and you go back and fix it, and once you get tired of having to fix it every time, you'll learn it, right? Hopefully before that, okay? But that's the way the learning process works. Okay, so kinetic energy is 1/2 mv squared, so we've got to figure out v for this, each 50 gram mass. Moving at, on a circle of radius 30 degrees, a radian is one radius of distance along the arc, so that each radian corresponds to 30 centimeters, because that's the radius of the arc of this thing, which should be obvious. So 3 radians, and I didn't put that down. I have 3 radians per second. I said I didn't write it down. Okay, 3 radians per second. So 3 radians corresponds to 90 centimeters along the arc. So the speed, v, without an arrow over it, it's the magnitude of v, which is the speed, right, is 90 centimeters per second. Because you go 3 radians every second, that means 90 centimeters along that arc, right? Now there's another way you could do it. You don't need the definition of radian. Okay? Well, you kind of do. If you know that there are 2 pi radians in a complete circle, you can do it by proportionalities with the circumference and all that stuff. It's much easier to understand what a radian is and the relationship between circumference and frequency and all that stuff. Okay, so we've got this, right? So the kinetic energy is 1/2 the mass and the total mass. You got 2 of these things. The total mass is 100 grams. Okay, just square that's 8,100. Multiply that by 50, and you get 455,000, I think. Grams centimeters squared per second squared. Right? Okay.
405.
I'm sorry?
Did you write it down wrong? 405. 4,000.
I said 455. Now is that right? 5? No, it might be 406. Hold on. 81 times 5, right? Is 405, not 455.
Yeah, 405.
Yeah, it's 405. Okay, I got confused with the 8,100 there and 90 and all that stuff. Okay, too many numbers running around in an empty head. Okay, make sense? Okay, so what's I? Can you solve for I? Can you find I?